The first concept check question is asking us to assign the stereochemistry of the alkenes shown. Here for each alkene, we need to rank the groups on each of the alkene carbons, then determine if the high priority groups are on the same or opposite sides. In the first example, on the left carbon, the alcohol group is highest priority. On the right carbon, the cyclopentyl group is the highest priority. These two groups are on the same side of the alkene, so this is a Z stereoisomer. In the second case, the right carbon doesn't have two different groups on it. The two groups are the same. So this alkene is neither E nor Z. There is no stereochemistry to this alkene, and there is only one stereoisomer of this structure. In the last case, on the left carbon, the chlorine is the higher priority, and on the right carbon, the methyl is the higher priority. They're on opposite sides of the alkene, so this is the E stereoisomer. In this question, you're asked to follow the flow of electrons indicated by the arrow to determine the reaction product. In this rearrangement reaction, the arrow begins at the carbon-carbon bond, and that means that this carbon-carbon sigma bond is the nucleophile, and this bond is broken during the rearrangement. It moves to the position bearing the cationic charge, which means we form a new carbon-carbon bond between these two carbons. To draw the product, you might find it helpful to number your carbons. So I'll number the carbons in my reactant, and then I'll make sure that I break the bond between carbons 3 and 7. And I form a new bond between carbons 7 and 2. And that means that my product will have 6 carbons in a ring. So I draw that ring structure, and then I'll attach the groups to it. On carbon 3, I have a methyl group, and on carbon 2, I have a methyl group. Don't forget where your hydrogens were and still are, because you need to account for them to keep track of the final location of the carbocation. And here the carbocation is on carbon 3. This last concept check question asks you to determine the products that you'd expect to form in the reaction shown. As we've seen, the alkene will attack as a nucleophile and attack the electrophilic hydrogen to form a carbocation intermediate. We form the more stable secondary carbocation intermediate. And now from this intermediate, the chloride could attack directly to give the product shown here in red. Or alternatively, there could be a methyl shift to generate the more stable carbocation. From this more stable carbocation, the chloride can attack the carbocation to now form the product that we'll draw in blue. And both products form in this reaction, but the blue product forms after the methyl shift will form in greater amounts. We call this the major product. The other product shown in red will be the minor product. This last concept check question asks you to determine the products that you'd expect to form in the reaction shown. As we've seen, the alkene will act as a nucleophile and will attack the electrophilic hydrogen to form a carbocation intermediate. From the carbocation intermediate, the chloride could attack directly to give the product that we'll draw here in red. Or alternatively, there could be a methyl shift to generate the more stable carbocation. And from the more stable carbocation, the chloride can attack the carbocation to form the product that we'll draw here in blue. And in this reaction, both products will form, but the blue one that forms after the methyl shift will form in a greater amount, and we call this the major product. The other, the red product, will be the minor product.